Okay, we are continuing talking about pandas, and I want to kind of spend some time discussing kind of the multi-index and hierarchical indexing. We saw a little bit of this last week on Friday, and I'm going to go a little bit more into it today. I still have to create a homework assignment with pandas for you guys, and so that should be coming soon, and we'll see there. So anyway, I guess I'll go ahead and begin. And so, as always, we import the necessary libraries. Pandas, NumPy, and we'll include matplotlib. This it should all be up on GitHub if you want to follow along, or you can just watch. Okay, and so here I'm gonna create a series with random integers drawn from 0 through 9, and I'm going to ask for 9 of these, and notice here I set up my index as a kind of this list of lists here, okay? And so I've got AAA, BBB, CCC, and 1, 2, 3, 1, 2, 3, 1, 2, 3 here. And so when I create this, this is what it looks like, okay? So these are just some random integers that were selected, and so now I've got a multi-level index with A, B, and C as kind of the first level, and 1, 2, 3, 1, 2, 3 as the second level of the index. And if we ask what is the index, it tells me that you've got a multi-level where the levels are A, B, C, and 1, 2, 3, okay, and then the codes. It encodes the A's, B's, and C's as 0, 1, and 2, and it encodes the 1, 2, 3 as 0, 1, 2 as well. Okay, and so again, when you do an index, the iloc index locator uses zero-based indexing, whereas the .loc we'll use whatever the index is. And so your index, you can specify an index to start with 1. But kind of the internal integer index always starts at 0, right? Okay, and so anyway, our outer index is this, and so I could do data.loc b, and this is going to select values from this series where the index is b, and so it's going to kind of pull out this chunk right here, okay? So where the value is b, it pulls out 1, 2, 3 is 5, 0, 0, okay, and over here you can specify via the inner index, and so the dot locator, we're going to specify that we want all from the outer index, and we want where the inner index has the value 2, okay, and so we could see it pulls out the 2 from A, which is 8, the 2 from B, which is 0, and then the 2 from C, which is 7, okay? So we see 8, 0, and 7, okay? What is the data type of this, anyway? What did I just do? Okay. So this, it comes back as a series, right? And if I ask what is, so that comes back as a series, and if I ask for the index on this, what will this report? It's going to report the index A, B, and C, right? Okay, we can take the data. So again, data is already appears this way, with a multi-index, and you can just ask it to unstack directly. Okay, and it's going to arrange it into a data frame where it's going to kind of keep the outer index this way, and it'll turn the inner index as kind of column headings. Okay, and so we have it appear like this, right? And if I ask for the index here, it's going to be ABC. And if I ask for the shape, what will the shape be? A tuple 3, 3, right? Okay, because it's a 3 by 3 data frame. Okay, you can undo the unstacking by stacking it back up, right? So here unstack looks like this, and if you take this and you tell it to stack, it stacks it back, okay? And we get back basically what we had up here. So unstack and stack are kind of inverse operations. So you can take this series with a multi-index, unstack them, and you get a data frame, and you can stack that back up, and it turns it back into a series with a multi-index. Right? The swap level will swap the levels of the multi-index. So here is what I've got right now, and if I do swap level, then it brings the 1, 2, 3s on the kind of the first level and the outer index, and then we've got A, B, and C as the inner index. Okay, and so you can do dot loc colon A, and it's going to pull out the 589 here after we swapped level, and ask for the locator. All right. It says swap level will keep the original order. If you want to sort them based on the new index levels, you can do this. All right. So you can do data swap level dot sort index, and now that we've sorted it, okay, now that we've swapped the levels and we sort it, it's going to gather all the ones together. So it'll go 5, 5, 1, and then it'll gather the 2's together, and it'll go 8, 0, 7. Okay, and that's what we have: 5, 5, 1, 8, 0, 7. Okay, and if you look at, but data itself so far is unchanged, right? Because we started off with data, and then we ran swap level, which kind of returns the new swapped level thing, and then we ran sort index, and so all of this just kind of returns copies of all of this stuff in place. Did I do this? Let me just also just show you data dot swap level unstack. So here's data dot swap level. What happens if I do unstack? Okay, so now it arranges it basically 1, 2, 3, and pulls out and makes 1, 2, 3 are kind of our row index, and ABC as our column index. Right? So these are kind of just things that we can do with a multi-level hierarchical index. Okay, data.sum. So again, data by itself looks like this: ABC 1, 2, 3, 1, 2, 3. Data.sum will sum everything together. These are it's going to add everything up, and you can sum based on the different levels. Okay, so if I do data.sum level equals 0, it's going to return back a value. So for the level 0 index it's going to give you the sum of A, the sum of B, and the sum of C. So the sum of A will be 5 plus 8 plus 9, which will be 22. The sum of B will be 5, and the sum of C will be 14, right? 22, 5, and 14. Meanwhile, we can also sum based on level 1. And so if we look at level 1, it'll be 5, 5, and 1, so that'll be 11. The 2 will be 8, 0, and 7, so 15, and we'll get 11, 15, and I think what's left over is like 15, okay? So that's what we get there. Okay, so you can, with the multi-level index, you can sum accordingly, right? So having this kind of hierarchical nature with the multi-index is quite a useful thing, right? So So we can do that. Here is, I'm just making up a new data set, okay? And I'm just taking the integers 0 through 5 and arranging them in 2 rows and 3 columns where, and I'm specifying the row index will be alpha and beta, and the column index will be 1, 2, 3, okay? And we give them numbers for these things. And so this is kind of what the data frame ends up looking like, okay? And so if you take stack, we're going to end up creating a multi-index. It's going to take the columns and stack them together, right? So it's going to give us an alpha kind of on the outer, and then 1, 2, 3 as the inner with 0, 1, 2, and then beta kind of the next, so you'll see, okay? So this is what we get, right? Alpha and beta on the outer, and then the inner index, the number will be 1, 2, 3, and I'll have the integers 0 through 5. Okay, and again, stack and unstack are inverse operations, and so when you stack it and you unstack it, you get back exactly what you started with. And you can specify how the unstacking should be done, right? So when I stacked it like this. This is what it looks like. And you can specify that we want to unstack the first level of the index, right? So if I want to unstack alpha and beta, then I'm going to kind of keep the rows 1, 2, 3, and then the columns will go alpha and beta, right? So here we're going to unstack. So generally it defaults to stacking the innermost level, but you can tell it to unstack, you know, level 0, right? And so this is what it looks like to unstack this thing at level 0. Okay, and you can also specify using the level name, right? So if I do unstack based on the letter, I'm going to get back basically the exact same thing I have here. And if I unstack based on the number, that's kind of the default thing, and it will keep the letters in the rows, and the numbered index gets unstacked to 1, 2, 3. Okay. You know, you know, unstacking operations can introduce some missing values here. So here I've got 2 series. Series 1, S1 is 0, 1, 2, 3 with the index A, B, C, D. And series 2 is 4, 5, 6 with the index C, D, and E. And we're going to kind of concatenate these two together to kind of stick them, and we'll have the keys, okay, as 1 and 2. And so so concat will produce a multi-index, and this is where we start off, okay? So we've got 1 where we've taken the A, B, C, D, and 2 will be C, D, E, and this is what we have here. And if I unstack this, however, okay, we'll see that we've got, so we're going to, you know, unstack, we'll kind of keep the outer, the 1 and the 2, and then we're going to have columns A, B, C, D, and going up to E. But we're going to have missing values for A and B and E, you know, at different locations here, right? So we can see that the 1 has values for A, B, C, D, but not E, and the 2 has values for C, D, and E, but not A and B. So so that's something that can happen when you unstack, because it's trying to match them accordingly. Okay, we can also say unstack on level 0, and it will do kind of reveal almost like the transpose of what the unstacking operation does. Okay, but you know, if you unstack it and you ask it to stack back up, it's going to kind of get rid of any of the missing values and kind of collapse everything. You have the option of saying don't drop the NA values. So when we unstacked it, we got this, and when we stack them back up, it misses, it ignores the missing values, but you can say don't ignore them, and it kind of preserves them as well. So it says E is missing and then A and B are missing, when we stack them back up this way. Okay, so these are just kind of options for dealing with kind of a multi-index and using the stacking and the unstacking operators here. Okay, is this so far so good? Okay, so here I'm going to use this data set called macro data. It comes from a package called stats models. So stats models is, I guess we'll talk about this a little bit later, but it basically lets you do statistics like regression and stuff like that, okay? Because in base Python, even NumPy and Pandas, there's not really, it's not easy to do linear regression directly, and so stats models is a way to do linear regression. We'll also look at scikit-learn later, which is this, a very powerful machine learning package. And you can, scikit-learn includes linear regression as one of the models you can fit. However, kind of from a philosophical standpoint, scikit-learn, like when you do linear regression, a lot of times you're curious about, like, I guess I'll talk about this later, but you're curious about like p-values and kind of the coefficients and all of that. Scikit-learn doesn't tell you any of that information. Basically you evaluate your fit based purely on cross-validation for scikit-learn, whereas stats model gives you kind of, as far as Python goes, this is probably the way you would get something that's familiar with R's kind of like linear models, the function lm that we use all the time in R. But anyway, this data set comes from there, and it's the United States macroeconomic data going from 1959 to 2009, so about 50 years of information. And I guess now that it's 2019, it could include another 10 years of info, but it goes to 2009, and so it has about basically four quarters per year. And so starting in 1959 Q1, it goes up to 2009 Q3, and it includes things like the GDP and the consumption expenditures and private domestic investment, and I don't know, stuff I guess that economists look at regarding the performance of the economy. And includes stuff like unemployment and population and inflation and the interest rate. Okay, so anyway, it doesn't really matter. We just load it up via the CSV. We can ask for the info, which kind of gives us the structure, and it says we've got 203 non-null floating point values. We can just take a look at the first like 5 rows or so. Okay. And this is what we see. All right, and so year is probably should be an integer, but it comes in as a float, so 1959, and then we've got the quarter, quarter 1, 2, 3, and 4, and it gives us numbers like whatever, all of these things, right? So inflation and stuff. Okay. So, right now, the index is just kind of the integer index starting at 0 and going up 1, 2, 3, 4, so on and so forth. And so what we can do is we can take the year and the quarter and create, kind of a time-based index. And so here, there's an option called period index. And here I'm going to say the year is the year, and then period index actually allows you to specify the quarter. You can specify things like the week and the month, and all of these things. You can just look up pandas period index, and it will kind of give you the options that you have. And so you can specify year, month, quarter, day, hour, minute, second. I guess maybe not week then. And so you specify things like that, and it'll create the periods for you. So we can just ask, what do our periods look like? And it says things like 1959 Q1, 1959 Q2, so on and so forth. And we see that if we start at 1959 Q1 and end at 2009 Q3, indeed we have kind of 203 of these things. Okay. And then as far as the columns, we're going to go ahead and we'll just specify we want real DGP, inflation, and unemployment. These will be kind of the columns that I'll extract. And so I create kind of these columns, and we're going to do a re-index. Okay. So remember, re-index will take kind of your data and it will force it to kind of conform to the new index that you've specified, which is different from just creating a new index entirely. But we'll go ahead and do that. And let me just kind of show you what data looks like at the moment here. Okay. So at the moment, we've kind of we've re-indexed the columns of our data to kind of conform to the columns that we've specified, right? So this re-index says columns equals columns, and so remember, there's two indexes in a pandas data frame. There's kind of the row index and the column index as well. And so we've just kind of forced the columns to conform to the columns that we've specified. So maybe I'll write that. Forces columns to conform to the column index we specified, which basically just means only include these columns that I've included. Okay, real GDP, inflation, and unemployment. Maybe I'll just do data.head here. Okay. We'll take the periods, which are currently 1959 Q1 and 1959 Q2, and we can turn it into a timestamp. And we can specify, at the end or the beginning, okay? And so the end of 1959 Q1 is 1959 March 31, 11:59, 59.999, okay? And then the end of Q2 would be June 30th, 11:59.99, right? You can specify other things. You can do like start, and it will be January 1, 1959, so on and so forth, okay? But I guess I decided to go with end date right here, okay? So this is what we get, okay? And this is how you specify just a new index period, okay? Specify a new index directly, all right? So keep in mind, currently our row indexes are still just this integer index that starts at 0 and keeps counting up, okay? And now what I want to do is I want to change this to this date time index thing. And so we're going to just specify by doing data.index is equal to basically this new index that I've created. Okay? So you just specify a new index directly. There's no need to call reindex. Okay? Reindex is for there's an index that's already established that you kind of want to keep, but you want to get it to conform to something new, like a new order, a new selection. Whereas if you just want to specify a new index directly, you just call data.index and you just replace whatever the current data.index is, right? So if I just say, the current index is just integers, and we want to replace it. So if I do data.index, this is kind of what it is. It's just a range index, okay? And so we're going to just replace this with this timestamp index that we've just created, okay? And so, so now that we have this, and we can, if I ask what data.index is, it's the exact time index that we've created, okay? Maybe I want start instead of 11:59:59:99. But okay. So now we can. Now that we have this, so this is currently my data. What would happen if I call stack on this? So this is what data looks like right now. And if I say stack it, what will I get? So what will be the first entry? 1959, March 31, 11:59, real GDP. And then the next one will be 1959, March 31, 11:59, inflation. And then the next one will be March 31, 11:59, unemployment, right? So if I do this, that's what we get, okay? GDP, inflation, unemployment, so on and so forth for all of these things, okay? We can call stack, and then we can call reset index, and it will take kind of the current index into a new column, and it creates an entirely new index in of itself, okay? So right now, if I stack this, let me just, if I do data.stack, and we'll just do the top 10 rows. If I ask, what is the index of this? What will it tell me? What's the index? So we've taken this data frame and we've stacked it. So it looks like this. And I just asked for the top 10 rows. But if I ask, what is the index of this thing that I've just created here? What is it? It's a multi-index, okay? And one level is the 1959, March 31, and June 30th, and all of that. And then the second level is going to be the item here, right? Maybe it's not just the top 10, but it gives you the whole thing. Okay. But it gives us this multi-index with kind of all of these different things. And I guess these are all the possible levels. This is kind of a cool looking pattern, but yeah, it just gives us kind of for the top few rows, it goes 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0. Okay. When you do reset the index, okay, it's going to take the current index and set them as columns, and then it just creates a new integer range index in the beginning. Okay, so maybe let me I'm going to just delete that. Okay, so it's going to take this thing and it's going to take each of these things and just turn them into columns like this, and then it creates a new integer index along the edge. Okay, so when we ask if I ask what the index of this is, it's, now we get basically, our integer range index again. Okay, so that's what reset index does. I know it feels like I'm dragging on about indexes a lot, okay? But that is really what a lot powers a lot of pandas type stuff, is that there's this important thing called an index, and it allows us to do operations quite quickly and conveniently. Whereas in R, there is no index, and so you have to make sure that your dimensions are always conformed exactly to match. I guess with Python, there's a little bit more overhead in that you have to kind of make sure that the indexes are properly specified, But if you have them properly specified, then you can kind of do operations and join them and do whatever, and it will automatically make sure all the operations are done so that the indexes match. Okay, here I call this long data. I take this data, I stack it, I reset the index, and I'm going to rename the columns to take the 0 column, the column currently titled 0, which is what we have here. There's no name here, and so we're going to just rename this column, which is currently called 0, and we're going to call it the value. Okay, and so it just gives us back the same thing that we had before, but now we have a date, an item, and a value. And then and if I tried to unstack this, it's not gonna work, okay? Because unstacking only makes sense if there's a multi-index specified. So if I say unstack, it just takes all 3 of these things and makes one giant series, okay? Where I think currently there's like 603 rows or something, and now we have 1,827 rows, okay? So just completely unstacked them, or 609 rows or something. So that's not what we want to do, okay? However, if you do have data in kind of this long form like this, and you don't have a multi-index specified, you can kind of effectively unstack the things by using a pivot, okay? So you can say, take this long data and pivot it, and it's going to, and you're basically going to specify what's going to become the row, the row index, and then the column index, and then fill it in with the value, okay? So when I do this, then it unstacks them, okay? So you can't unstack if you don't have a multi-index, right? So unstack requires a multi-index for it to do it. But if you did want to do something like take the values and item and turn them into column headings, effectively unstacking them, okay? But again, unstack only works with a multi-index. You can call pivot. And when you call pivot, then it will do what you want accordingly, okay? Maybe I'm gonna change all of this to start rather than end. So let me just go through this. All right, this makes it a little bit easier. Okay, so that's what we have there. All right. So so that's nice. We have a few more operations that that we can do with pandas, and one is to do kind of grouping operations, and we've seen this before, but I just kind of wanted to designate some time specifically with kind of some manual examples here. So here we've got a data frame, and we're going to use A, B, and A for key 1, and key 2 will be 1, 2, 1, 2, 1, so on and so forth. And so so I'm going to create my data frame accordingly, and I just have these columns, right? Key 1, key 2, data 1, data 2, and note that I have A1 duplicated. Not duplicated, but I've got key 1 A, key 2 1, data 1 is 5, and data 2 is 11, and then I also have an A1 916. Okay, so if you take this data frame, and right now we just have a range index from 0 to 5 or 0 to 4. I get 0, 5. Here our grouped is I'm going to create take this data frame and group by key 1. Okay, and so when I do this, it just tells me you've got a grouped generic series grouped by object. Okay. So we can do grouped.mean, and because I've grouped it by key 1, it's going to give me a mean for A and a mean for B for the numeric variables where it's able to calculate a mean. So for data 1, it's going to average 5, 11, and 9. So that's going to give me 25. 5 plus 11 plus 9 is 25 divided by 3, so I'm going to get like 8.33. And then for data 2, 11 plus 5 plus 16 is like 32, so I'm going to get like 9.67. And then grouped by B, it's going to just have these two numbers, 12 and 8 will average to 10, 15 and 0 will average to 7.5. Okay? What did I... Oh, I guess... Oh, I'm sorry. If I do the grouped and I... sorry, I did this wrong. It'll just group mean kind of all of the numeric values together. Okay, so 5, 11, 5, 11. So if you take these four numbers, wait, why is this 20? Yeah. Okay, so this adds up. No, am I going crazy? How did I get 15 for B? 20, 25, 30, 20, 35, and 0.
I think it just takes data 1 column and then does A, groups by A and then groups by B.
Oh, yes, because I specified data 1. All right, sorry. I was going crazy because I specified data 1 and I missed that when I'm reading. Okay, sorry. Yes, so we're only looking at data 1's column and grouping it by the mean. Exactly. Okay. When we don't specify the column, if you just say df and then group by key 1 and then do the mean, then it will give me, I think, the results that I wanted, where you get 8.33 and 10 for data 1 and 10.67 for data 2 and 7.5 for data 2. Yeah. Sorry, I don't, not paying attention here. Okay, you can group by both key 1 and key 2 and call the mean. Okay, and so what is that going to do? It's going to return 4 rows. We're going to have a row for A1, a row for A2, a row for B1, and a row for B2, and basically it's going to present these things, 11, 5, 12, 15, 8, and 0. And it's really only going to find the mean of 5 and 9, which will be like 7, and the mean of 11 and 16, which will be like 13.5. Okay? But everything else will kind of remain... oh, again, sorry. Looking only at column data 1. Okay? So we specified data 1, and so it's going to return basically the same. 11, 12, and 8 remain. Okay, 11, 12, and 8. We get 4 rows back, and it averaged basically the 5 and the 9 together because those are kind of the values that we have. Okay, this thing, when you group it by multiple keys, okay, you have a multi-index, and so you can do things like stack and unstack. Okay. So here I can unstack it, and we'll get, key 1 is grouped by A and B, and key 2 is grouped this way, okay? Here's kind of an interesting thing, all right? So data df, okay, is our data frame, right? So I'm going to just take this column, 5, 11, 12, 8, and 9, okay, data 1. We're going to take data 1 of our df data frame. We're going to take this column 5, 11, 12, 8, and 9, And you don't even have to group by the values in the data frame itself. You can give it an entirely different array. So here I've got Ohio, California, California, Ohio, Ohio, okay? And the years 2005 and 6 and whatever. And we can have them grouped by the state and the years, okay? And it will do it, all right? So for California 2005, it's going to take the second entry, and I guess that's it. The second entry is going to be the entry for California 2005, which will be 11, okay? And if we pay careful attention, it's on Ohio 2005 is the value that shows up kind of twice here. And so this value 6.5 is the average of the first and the fourth values in data frame data 1. The first is 5 and 8, and the average of those two is 6.5, okay? So you can, so this is kind of a neat and handy thing, is that within the data frame itself, you don't even need to specify the groups or even like bind that column in there. You can just have an entirely separate index that, if you know aligns properly with your data, you can you know, have that grouped by that, okay? Oh, I think I've already done this, where you can do the operation. You can group by the key and do the mean, or you can group it and it will apply it to the entire data frame. Okay, so group, this should be two separate operations. So here's there's one, and then here's the other, okay? And so you can have it grouped by one of the keys, key 1, and it will apply the mean there, or you can have it grouped by the two keys and it will apply the mean there. And then size will just kind of give you the count. And so this will, everything will have a count of 1 except A1, which will have a count of 2, right? So everything has a count of 1, and A2 has a count of 2. If you group by something, so here again, here's our data frame, you can have it iterate over groups themselves. So when you do a df group by key 1, it's going to basically create an iterable that unpacks into two pieces, the name and the group, okay? So you know, you can print, I don't know, oh, I guess I've done this group.mean or something like that, right? Okay. So so it says for name and group, so we're going to print the name, which is A, and then the grouping information looks like this, where it pulled out group A's things, and then I asked for it to print the group mean, and so it's going to print the mean of data 1 and the mean of data 2, and then a horizontal bar. Okay, and then now we print the mean B, and then we print the group itself, which is going to be kind of this subset data frame, and then we ask for the mean of data, and it applies that there. Okay. Similarly, you can do it for here, and so this is kind of a neat thing if you want to. Oh, this is kind of funny. We said print group.sum, right? And so sum can actually apply to things like character columns, okay? Because you can take characters, and when you add them together, it kind of just pastes the characters together. So so prints the name, which is 1. The group information is basically that subset data frame. And then when it sums it, sum of key 1 is ABA, sum of key 2 is 111, sum of data 1 is you know, 26 and 42 and something like that. So it's kind of funny that you can actually call a sum on a character vector or character column, and it applies there. Okay, we'll I guess it's perfect timing. We'll end here, and I'll see some of you guys in a few minutes for your group project proposals.